Hello everyone, welcome back to Soundarya Study Zone. In the previous videos, we have already discussed about the explanation of NFA. So today, let's jump into some of the simple examples of NFA. Let's begin. So the first example is NFA to accept strings of A's and B's starting with A. So same like DFA, what you have to do here, at first we have to write the alphabets, right? So the alphabets are A and B, and what are all the languages? Same like DFA, the languages are starting with A, which means we can have only A, or starting A, at the end we can have anything, and A, and we can have B, or A, B, or A, like this, right? So this is how we represent languages. So the main thing is, if we have only one string, how many states we have to take? It's very clear for you now. If there is only one symbol at the starting, we have to take two states. So the two states are Q0, which is a starting state, and Q1, which is the final state, right? So if these strings start with A, then this string should get accepted, right? Same like TFA till now. If the string starts with A, it should get accepted. At the end, we can have A or B, right? So this is how we represent NFA. Now let us examine what is the difference between DFA and NFA. Okay. So for this example, what I will do is, I will write the transition diagram of DFA here. Okay. So in DFA, this is same. Q0 on A, it should move to Q1, right? Starting, at the ending we can have A or B, which means starting I should have A, ending I can have any characters, right? Here I can have A or AAB, anything like that. So here in DFA, we have to check all the transitions are done for all the input symbols, right? So our input symbols are A and B. So we have to check. For A, there is already a transition that's done, but for B, we didn't have any transition. Shall I do like this? Shall I take the transition here? No. Why? Because if I get BA, then the string will get accepted, but our question is starting with A only, so we can't write it like this, right? So now, if I get B, I should get into the new state, that is a dead state in the DFA, right? But here I didn't represent Q0 on B what to do, right? Q0 on B what to do, I didn't represent. And I can have another one thing like this also. Q0 on A, it can be there in Q0 state also. So in DFA we can't write it like this, because for one input symbol there should be only one transition for each state. But here there are two transition. This one is also wrong in DFA, but here in NFA we can represent it like this also. So this is correct in case of NFA. So here I didn't represent the dead state, right? QD, I didn't represent it this one. So if we didn't represent B input symbol, indirectly it means that it is going to dead state if I get B. So no need to represent this one. Is it clear? So no need to represent this one in the case of NFA. If we didn't mention that input symbol, then that is clear that if I get B, it will be moving to dead state. So now you might get confused that here there is one input symbol A and there is another input symbol A. So what to do if I get A as input symbol at the starting, right? So what NFA will do is, I will show it here. So what NFA will do is, here there is a machine, right? So the machine will do the work simultaneously, which means it will do the task at the same time. So what it will do is, it will, so let's take the this string is A, B. Okay, so let's check for this. So starting symbol is A. So what machine will do is Q0 on A. In one case it will be moving to Q0, right? Q0 on A, it will be moving to Q0 only, or it will remain in this state Q0 only. Okay, now in this case Q0 again on A, it will be there in Q0 state only. Okay, and Q0 on B, there is no path, so it will lead to empty set. So if there is no transition, we have to represent it with the help of empty set. Okay, so this is one case. In another case, we have Q0 on A, it will be moving to Q1, right? And then Q1 on A, it will be there in Q1 state only. Now Q1 on B, it will be moving to Q1 on B, it will be there in Q1 state only. So Q1 on B, it will be there in Q1 state only, which is the end of the string, and I am there in final state. So this is not a correct string. So this is a correct string, right? So what I have to do now is I have to check whether any one of the transition is taking us to the final state. Yes, one transition is taking us to the final state. So the whole transition diagram is correct. So let's take, I have 5 transition diagram like this. Okay, if 2 of the transition diagram is taking me to the final state, then the whole transition diagram will get accepted. So the main thing in NFA is it will check all the possible ways or all the possible transition at the same time, like this one and this one at the same time. If any one of the state or any one of the diagram is taking us to the final state or final destination, then the transition diagram will get accepted. So this is how we represent NFA. So it is very simple and no need to represent all the transition diagram for all the input symbol. Okay, so only whichever input symbol is required, that one only we have to represent. So that is the solution for first question, that is starting with A. Now you might get confused how to write the transition diagram, right? So I will write the transition diagram here. We have Q0 and Q1 as the state and A, B as the input symbol. Now what I have to do is Q0 on A, it will be there in Q0 state also, and it will be moving to Q1 state also. We have to write it like this. Okay, and Q0 on B, it will be not moving to any state, so I have to represent it with null set. Okay, and then Q1 on A, it will be moving to one state only, that is it will be staying in Q1 only, and Q1 on B, it will be staying in Q1 only. So this is how we represent truth table in this NFA. Okay, so this is how we represent transition diagram and transition table. So let's move into the next example. So the next example is NFA to accept strings of A's and B's ending with A. So in the before example, we have learned how to write NFA for starting with A, right? So if you are clear with that example, you can try this one without seeing. Okay, so just pause the video and try it and check, or else I will explain it again. Please go through this. Okay, so for ending with A, what are all the alphabets? Alphabets are A and B. And what are all the languages? Languages can be A, because ending one can be A, or starting we can have anything, ending it should be A, which means starting we can have B or A, it can be AA. Here these all, it can be anything, ending it should be A. We have to accept ending with A and we can ignore everything else. So here the transition diagram should be like Q0 on A, it should be moving to Q1, right? So because if this string ending with A, it should be moving to Q1 state, one thing. and at the starting we can have any symbol, right? So starting we can have any symbol A or B, that is one case. If it ends with A, it should move to final state, that is one case. And at the final we can have A, so on till A, right? So here if you get any number, n number of A's, we should be self-looping n number of times in Q1 state only. And in Q1 state, if I get B, which means I have A, B, okay. So A. But in the final state I got B, so I should be moving back to Q0 state because this one shouldn't get accepted, right? So here also, here the difference from the first example is, in the first example we didn't have all the input symbol for all the state, right? But here we have the input symbol. For Q0 we already have AB, and Q1 also we have AB. How it is different from DFA, I will tell you. So in DFA, for one transition state, we should have A and B only one time, right? But here I have A two times. This is the difference from DFA. We have multiple input symbol for the same state, okay? So here I have the example of AB, AA. So what the machine will do is, it will do the task at the same time, that is Q0 on A in one thing, that is it will be remain in the state Q0 only. In other case Q0 on A, it will be moving to Q1 state, okay. And in this case Q0 on A, it will be there in Q0 state only, and if it gets B, it will be there in Q0 state only. And if I get A, one thing, it will be remaining in Q0 only, and if I get A again, it will remain in Q0 only. This is one case. And in next case, if I get A, I will be moving to Q1, and if I get B here, I will be moving back to Q0, and if I get A again, I will be moving to Q1, and then if I get A, I will be there in Q1 state only. Q1, right? This is two cases, and there is one more case I will tell you. Q0 on A, it will be going to Q0 only. Q0 on A remains in Q0 only. Now Q0 on A, it can move to next state also, right? Q0 on A, it can move to next state also. And Q1 on B, it will be going to Q0 state, and Q0 on A, it can be staying in this state also, or it can move to this state also. I will take this scenario now. It will be going to final state. There is another scenario where all these things are same. I will write here Q0 on A, it will be moving to Q0, and Q0 on A again, sorry, Q0 on, oh I did one mistake here, I took the example of AA, here, okay. So I will take this same example here also, AA, Q0 on A, it will be there in Q0, and Q0 on again A, it will be moving to Q1, and Q1 on B, it will be moving back to Q0, and Q0 on A, it will be staying in Q0 only. So I wrote 4 possibilities, and there might be many other possibilities. The machine will check all the possibilities, okay. After checking all the possibilities, what the machine will do is, it will check which are all the transitions that are taking us to the final state. So there are 2 transitions which are taking us to the final state. So our whole transition diagram is correct. At the end we need at least one of the transition which is taking us to the final state. So if any one of the state or string or transition is taking us to final state, then that's NOP. So this is how we represent the transition diagram of NFA, and the good thing is machine will not waste its time. It will check all these things at the same time. That is very important. So this is how we solved example for ending with A. So in today's video we have solved two examples for NFA, right? So I hope these examples helped you to understand about the simple examples of NFA. So if this video helped you, don't forget to like the video, subscribe to my channel and share with your friends who are learning finite automata theory. Thank you.